Hi, welcome to GEETHA'S classes. Today we are going to see about the course Discrete Mathematics ME 8351. So we are going to start a new unit, Unit 2, Combinatorics. Okay, let us see what are all the topics under Unit 2 Combinatorics. So Unit 2 Combinatorics. So under this you are having one important topic called the principle of mathematical induction. So induction is done by using induction hypothesis. So you have studied in 12th standard induction hypothesis. What is induction hypothesis? So you have to check for 1 is true and then assume for k is true, and then you have to prove for k plus 1 is true. Finally, you can give p of n is true, right? So that is induction hypothesis. Induction hypothesis is done in 4 steps, okay? So here, this is the definition. So there are two principles of mathematical induction. So one is the first principle of mathematical induction. Another one is the second principle of mathematical induction. It is otherwise known as strong principle of induction. Second principle is otherwise known as strong principle. Let us move on to the definition for first principle of mathematical induction. So I have already told induction can be done in 4 steps. One is true, assuming k is true, proving k plus 1 is true, finally n is true. Okay, so you have to keep these 4 steps in mind. So this is the definition for first principle of mathematical induction. So here let p of n be a proposition, that is the proposition corresponding to positive integer n. First one is if p of n naught is true for some integer n naught. So this first step is nothing but the basis step, BASIS, basis step. Okay, so in this step we are going to take n naught to be 1. Starting value is 1. Okay, so we have to prove that p of 1 is true, right? In the place of n naught we are going to substitute 1. If the question in terms of some other number, that is apart from 1, it may be start from 2 also. If it starts from 2 means you take that number as the initial number. Okay, so n naught is nothing but the initial number, right? So first step is we are finding p of n naught is true, right? Second one is if p of k is true for arbitrary integer k greater than n naught. So you note the word for arbitrary integer k. Okay, so this one p of k is true. We are assuming p of k is true for some arbitrary integer k greater than n naught. Then p of k plus 1 is also true. We are proving for k plus 1. Finally, then p of n is true for all integer, right? N greater than or equals to n naught. Okay, so first thing is basis step. Assumption of p of k is true, that is inductive step. Okay, inductive step is p of k is true, that is assuming k is true, right? So then proving k plus 1 is true, finally n is true. Okay, so these are the steps followed in principle of mathematical induction. This is our first principle. First principle, we are choosing arbitrary integer k, right? Now we are moving into the second principle. The same definition we are writing for second principle also. So let p of n be a proposition corresponding to positive integers n. If p of n naught is true for some integer n naught, so we are checking for n naught true. N naught, the value starts from 1. So p of 1 is true. Okay. Now the second condition, if p of k is true for all integers k greater than n naught. So for all integer k. Okay. So in first principle we have taken arbitrary integer k. Okay. So here we have taken for all integer k greater than n naught. Then p of k plus 1 is also true. Then p of n is true for all integer n greater than or equals to n naught. Okay, the definition is same for both the principle of induction. Only the difference in the second step, in first principle for arbitrary integer k, in second principle for all integer k greater than n naught. Okay. Thank you.